Okay, so in general properties of wave, today we are going to discuss about a concept of ripple tank. Basically, ripple tank is a setup for the experiment to find out the properties of waves like reflection in waves, because in normal daily life use we observe light rays, and we know that light rays can reflect and they can also refract, like they will bend when they transfer from air to water or glass, like that. So basically, a ripple tank helps you to identify the different properties of waves like reflection, refraction, and diffraction. So you can perform easily all three concepts with the help of ripple tank. And this is the most important topic in the first chapter of wave, in the properties of wave, because most of the questions are related to ripple tank in your exams. So first of all, for ripple tank, let me show you short animation. So you will have some type of imagination in your mind that what we are actually going to do with ripple tank and how we perform experiment. And in your past paper, one time they also asked you to draw a sketch diagram or rough diagram for the ripple tank also. So I will also show you that how to make just a reference concept for ripple tank. Okay, so this is the ripple tank, and let's suppose, because in waves we discussed that there is a continuous disturbance of waves. So you can see this is the setup. This is a very shallow tank. We don't require very deep tank or very heavy process for this. So for ripple tank, we just take a shallow tank, and the base of that tank should be of plastic or glass, because we require light reflection of the water waves on the screen, that is on the surface of the table or anything. So you can see that's why the central part of the ripple tank is made up of plastic or glass. And we just filled it with water. And this color is just for the representation, so your representation will be clear, because in water you know that background is also white, so might be we are not able to observe that waves very clearly. So this is the setup of ripple tank. Plus we also want to generate a continuous vibration, continuous wave. So for that we set electric motor. So in electric motor automatically produce vibration with constant time period. So you will get constant waves, and you can also generate circular wave, a linear waves from this generator, because it works on the AC. That is not compulsory that what type of generator we are using. Our main focus is on the property of wave. So you can see when you just drop liquid into it, so it starts to make waves into the water. But you know that when you drop by yourself, so there will be like non-uniform motion of the waves, because sometime might be there will be two or three drops at a single time. And you can see there is a reflection or a shadow of those waves on the table. And you can generate a linear waves also. So basically it depends upon the situation what type of waves you want to generate. So simply we use electric motor. Okay, now you can see that there is an electric motor and a spherical ball is connected with it. So when this motor starts to vibrate and this spherical ball also starts to move in up and down position like this, so it continuously generates wave into the water surface, right? And this is the reflection of that. Now you can see there is a proper reflection of that wave, and you are getting proper pattern on the surface of the table or on the screen. And you can see when you place any object, so waves are reflecting from that. So simple is that we use this setup for the vibration in the water waves or in the water surface. And you can place any other obstacle, so waves will reflect back from that surface. And we will also discuss that how refraction and diffraction take place. Now you can see linear waves are moving. So this is the concept of ripple tank. So with the help of ripple tank, you can easily generate the water waves, and with that water waves, you will be able to study the properties of wave like reflection, refraction, and diffraction. So basically, we use this experiment to discuss three important properties: reflection, refraction, and diffraction. So these are three processes that we have to discuss. Okay, sorry, it got disconnected. So just for the journal representation, we just draw a shallow tank. And we just place motor with a paddle to vibrate or to make vibration in the water. So we are using motor with the vibration paddle, and also we are using light over it, and water waves are generating in the glass. This is shallow glass tank. And you will get the reflection or the shadow of these wave on the ground. And you know that when we are observing the waves on the ground, so definitely that will be like a flat wave. We will not able to observe the 3D picture, and we are not able to mark the 3D diagram. So we only used to mark like this. In video, you observe that some part will be dark and then bright, then dark, bright like this. So you will get pattern like this: dark, bright, dark, bright. And there is a concept of wave front also. Basically, you know that for longitudinal wave, it is very simple. Okay, no issue. We just started, so it is just a start of the topic. So basically, for longitudinal wave, you know that longitudinal waves move back and forth. So for that, we can easily draw a diagram on paper. But for transverse wave, we know that the vibration of the particle and the direction of the motion of the wave is perpendicular to each other. So for that, we are not able to make a 3D diagram or a 3D concept for that. So for simplicity, we use the concept of the wavefront. And the meaning of a wavefront is, so wavefront represents corresponding points of a wave that vibrates in single orientation. So basically, the meaning of the wavefront is we know that particles vibrate perpendicular to the wave direction. So the motion of the particle will be uniform. So all particles vibrate to the crust, then to the trough at a same point, and you will get a uniform line of that single motion. So we use the concept of the wavefront to make a waves. In simple words, we can say that we are marking a straight line, just like this reflection, and from this reflection, we can identify that the light part will be the crust of the wave, and the dark part shows you the trough of the wave. So in this way, you can easily identify crust, trough, just like the orientation of the transverse wave, crust, trough, like this. Okay. So that's why we are using the concept of wavefront to simplify the diagram of the transverse wave, right? Any confusion?
No, sir.
No, sir.
So you always get in your paper in the wavefront form in a single line. You will not get like a 3D wave diagram when they ask question related to the components of the wave. So then they will give you the diagram like this. Otherwise, we use to draw a straight line if we are not talking about the components, if we are talking about something else. So this is the concept of wavefront from the ripple tank. And now if we talk about the reflection, so reflection is a very common process, and we already know about the light. We also study in lower secondary level about the reflection, that light reflect with the same angle, with the angle that it strikes the surface. So if we talk about the reflection surface, so reflection process is very simple. In reflection, when waves hit an object, such as a barrier, just like the barrier you observe in the video, you may place any wooden bar or any plastic material or any type of barrier. So when waves strike that barrier, or you can also take the example of the sea waves when the water waves are coming towards your side, if you place anything in front of it. So definitely water waves strikes from that barrier and reflect back. so they can be reflected. So in the reflection of waves, whatever type of waves we are using, either light wave, water wave, or sound waves, any type of wave, so this concept remains same for each type of wave we are using in the concept of the wave section. So let's suppose if water waves are moving from left hand side in this direction. So this is the direction of the propagation of the wave when it strikes the wall of the barrier, and it will reflect back with the same angle. And if you want to make the wave fronts, so you can also mark the wave fronts just like the normal linear lines. So they are moving like this. And secondly, on the other side, they will reflect back with the same angle. And to measure the angle, we need to draw a normal line like this. This is our normal line. And this normal line is always perpendicular to the reflecting surface. You can see it is completely perpendicular to the red line, which we are using for the reflecting surface. So this red line shows you the reflecting surface. And this is the angle of incidence, and this is angle of reflection. So I represents the angle of incidence and R represents angle of reflection. So basically incidence and reflection both are uh, increasing, or both are directly to each other. If angle of incidence increase, so definitely angle of reflection will automatically decrease. So in simple, if they ask about the reflection of waves, so we can simply write that in reflection of wave, angle of incidence will be equals to the angle of reflection always in any type of wave. Either we will also discuss this concept in the light chapter, and we will also discuss this concept in sound chapter, because reflection is very common process in our daily life. So that's why this concept is very much simple, right? So your angle of incidence will always equals to the angle of reflection, right? Any confusion? So this is the first idea about the ripple tank. And if we talk about the next process, so next process is very much important, because that is like something different from the daily life process that we observe in our daily lives. So next process is refraction. And you know that refraction means bending of light. If we observe this refraction in the light, again, because we are using light in our daily life, so if we use refraction in our daily life, so let me show you some pictures so that will give you idea that how refraction works.
Actually, it's just the bending of the light, no?
Yes.
It's when waves transfer from one medium to another, right?
Yes. Yes. So if you just simply perform this experiment, and you definitely observe this in your daily life,
Yeah.
so you will find that this object will be like broken in the water surface. Or if you place any football
If
over
you
the,
place your hand in water as well.
yes, so you will feel that the object in under the water or behind that water have some different orientation as compared to the upper part of that object. So basically this happens because of the bending of light waves, because light is also a type of wave. So this also shows you the concept of the refraction. But for refraction, there is one condition, you know, that we have to change the medium. To bend the waves, we have to change the medium. So that's why you observe this experiment in water and glass, because glass and water have different type of medium as compared to the water, because water is rare medium, very light medium, because molecules are not tightly packed. In water and in glass, you know that they have different scenario, they have different orientation of molecules. So that's why uh, you feel object in different orientation because of refraction process. So for refraction, it is compulsory to move from one medium to another. So when waves enters a different medium, so their speed can change, and due to that change in speed, you will feel the concept of refraction over there, and the wavelength will also change. So wavelength can increase or decrease. And now let's consider the concept how this refraction is possible in the water waves or in any types of wave, because we are talking about ripple tank phenomena. So definitely we start.
Different densities.
Yes. So let's suppose if we take the example of swimming pool. So in swimming pool, you observe that the stairs area of the swimming pool is shallow one, right? Because there
Yeah.
are stairs on that. So that area is shallow as compared to the middle section of the swimming pool, because that area will be the
It's
most
going
deep
down.
area, right? And they will also make like slide the surface under it, because it will also change the depth of the water. So you can also change the depth with the surface under the water surface. So let's suppose if we take the comparison, on left hand side we have deep water, and on right hand side we have shallow water. And again we consider water waves as a wavefront. So straight lines we mark for the water waves. So we have to make equal distance between the waves. And when it enters the shallow medium, so when entering the shallow medium, their direction will slightly change, because we observe this effect. So from this effect, we can identify that direction will also change. And there will also a change in the wavelength, because if we compare the wavelength from the first diagram, so this is the wavelength, because previously we discussed that the light color line shows you the crust, and the dark area shows you the trough. So the distance between two consecutive crusts is equals to the wavelength. So we can easily mark wavelength from this diagram. Plus, if we just draw the shallow medium waves, so they will be like this. So you can easily feel the difference between the distance between the waves. So this is your wavelength now. So your wavelength actually decreases in shallow medium. and the direction also changes from a straight one to other direction like this. So what actually we observe if we compare these two mediums? Okay, so we are talking about the deep water and the shallow water, or you can also write deep, medium, shallow, medium. It is not compulsory only for water. It depends upon the type of medium we are using. So we observe that there is a difference in their speed and also difference in the wavelength. So first difference we can easily compare from the diagram, the difference of the wavelength. So if we talk about the wavelength, speed and frequency. So we need to compare these three properties between these two concepts. So in deep water, your wavelength is greater as compared to the shallow water. And we have short wavelength in shallow water and a large wavelength in deep water. And if we talk about the speed, so again, if you consider the example of the sea water, so when water waves it starts to generate from deep water, so you feel that waves are moving with very high speed. And when they just strikes the edge of the beach or the water surface, so the speed will automatically decrease time by time. So basically in deep water, speed will be greater, and in shallow water, the speed of the water wave or any type of waves will be slower, right? And if we talk about the frequency, so frequency remains same in both cases because the concept of frequency is number of waves per unit time passing through any specific point. So basically, you know that when you are moving with high speed, so your wavelength is also greater, right? Let's suppose if you compare with very simple example, like if someone has writing speed of that he can easily write one page in 2 to 5, let's suppose 5 minutes. He can easily write a complete page in 5 minutes. And if we compare with another student, and that student is able to write only 10 lines or like half page in 5 minutes, right? So if you provide a greater time for the second student, so definitely he will also complete his one complete page as compared to the first student. So basically, deep water also have greater wavelength. So this medium or this water wave have to cover a large wavelength with high speed. And if we compare with the shallow water, so in shallow water, your wavelength is short and speed is enough to complete the same number of waves in given time, right? So that's why frequency remains same. If let's suppose if we are doing that, one medium has high wavelength and second medium has a short wavelength, and if we consider both moving with same speed, so then your frequency will be different, right? Just like the example of those students, if you give same time to both students, so definitely the student with fast writing speed will cover more lines, and that student with slow speed will cover less lines as compared to the first student. But if you give them the task to complete one complete page, so their time will be different, but definitely they will complete the same page after some time. So this is the scenario for deep water and shallow water, because in deep we have high wavelength plus we have high speed, so we cover number of waves in unit time. And then if you compare shallow water, so shallow water have short wavelength and slow speed, So this speed is enough to complete same number of waves like deep water in the given time. So that's why their frequency remains same. Okay.
Okay, sir.
And to measure the speed of the wave, so the old formula of speed is for dynamics and the kinematics, we discuss distance over time. But this time, we don't have any concept of a linear distance. We have a concept of wavelength, and wavelength is completely different from the normal concept of distance. So that's why we use different formula. V is equals to F into lambda. So this is the formula for speed of wave. So if you want to calculate the speed of wave, or let's suppose unknown frequency or unknown wavelength, so we use this formula to calculate any unknown quantity, right?
Yeah, you're right.
And one more important thing, last time we discussed about frequency and time period. So last time we discussed about frequency and time period. And if you compare frequency with time period, so there is inverse relation of frequency and time. So sometimes in question, the value of frequency is not given or value of time period is not given, but the opposite value is given. So you can also calculate that unknown value with the help of this relation, that frequency is inversely proportional to the time period. And if you just compare the definition, so you will get the concept that in frequency, we are talking about number of waves. And in time period, we are talking about time to complete one wave. So let's suppose if there are, or you can also write this formula like this. And if we compare their properties, so you can easily identify, let's suppose if we have two different waves. So let's suppose this is the first wave, which completes in 1 second. And we have another waveform. And this wave also takes 1 second. So in which diagram you feel frequency is greater? The first or the second? Greater
First
frequency.
one.
So in first one, you have frequency greater as compared to the second one, but you have very short wavelengths, right?
Yeah.
Yeah.
Yes.
And definitely, you can see that in 1 second we complete around 1, 2, 3, 4, around 5 waves, right? Roughly. So definitely the time to complete one wave will be equal to around 0.2 seconds, right? So your time period is also short.
Yes.
And if we increase the wavelength, so now we have greater wavelengths. And definitely your time period or time to complete one wave is greater. Now you can see we have only two waves over here. So one wave takes 0.5 seconds. So your time period will also increase as compared to the previous example. But your frequency will decrease because we have less number of waves in the same time. So this is the concept of the frequency, wavelength, and time period. So basically, frequency is inversely to wavelength plus frequency is also inversely to the time period. So this equation will also help you to identify some unknown values in the question sometimes, because sometimes we are thinking about V equals to F lambda, but you can also find unknown value by this relation also, because they also used to test in exams for this relation, because this is also a very theoretical concept and very simple concept, right? So this is the concept of refraction, different medium concept, and their speed, their wavelength, and their frequency. And the last phenomena from the ripple tank that we derive from it. And after a ripple tank, your first chapter will be completed, right? Because ripple tank is the most important topic in the first chapter, properties of wave. Because journal properties are basic, we have to learn about all the terms, and we just apply all the terms on ripple tank. So that's why they ask many questions related to the ripple tank. And the last phenomena is related to diffraction. Okay, so in diffraction process, diffraction is almost close to the reflection, but there is a slight difference between diffraction and reflection process. So basically what happens when waves pass through a narrow gap, the waves spreads out. So basically, if we allow waves to pass through a very narrow gap, so the waves will spread out after passing through that specific narrow gap. So let's suppose if we consider a narrow gap like this. So let's suppose if we have again, so let's suppose waves are moving like in a linear form, and when they pass through a narrow gap, so after passing through this narrow gap, so they will spread out and their shape will automatically change. And if gap is very narrow, just like in the diagram, so it will make a semicircle form like this. So in this way, you will get your waves after passing through this narrow gap. So you will get semicircle pattern after passing through this narrow gap. And this is your representation. Initially, waves are moving completely in a straight line, and then they starts to spread away from the center like this. So this is the representation of the wave. And secondly, if we allow to pass through a slightly greater gap, not very narrow, like if we have gaps like, so you can see there is enough gap to pass from the center. We don't have very narrow gap, just like the previous situation. So in this situation, if waves are trying to pass through this gap, so shape will be different. So your shape will be like, because from the center part, waves are moving in a straight form, but from the edges, their shape will be again spread out as compared to the initial situation, right? So center part is moving straight, but from the edges, they are moving in away direction. And there are two important things. Let's suppose if we talk about the first diagram, like this one. This is our first figure, and this is our second. So in first figure, when waves pass through this gap, so your wavelength will be greater than the gap size, because we know that gap size is already very short. So definitely the size of the wavelength will be greater than the size of the gap. And if we talk about the second diagram, so in second diagram, you can see gap size is greater as compared to the previous one. So definitely your gap size will be greater than the wavelength. And this is the scenario for the wavelength when they are moving through different gaps, right? So when the gap is going to increase, so your wavelength starts to decrease. And when when the gap size starts to decrease, so the wavelength of your,
The wavelength increase.
yes, your wavelength will increase, right? So this is the concept. And this is the final concept from this properties of wave section. And this is the third concept from the ripple tank, right?